was told this is going to be the most commercial talk, so be ready. So welcome everyone to our Firebase talk here at Pragma Conf. I'm Sebastian, and I'm here today to talk to you about how you can create robust and scalable backends for your mobile applications using only Firebase. Our product offerings for iOS, Android, and the web include a variety of SDKs that help you both develop and grow your app. Earlier this year, we introduced Cloud Functions, which allows you to combine our offerings in a completely new and serverless way. And just last week, we announced Cloud Firestore. Cloud Firestore is our new database product that combines the ease of use and the real-time capabilities of the Firebase real-time database with the advanced feature set and scalability of Cloud Data Store. With Cloud Firestore, we're adding support for a completely new data model that makes it incredibly easy to structure your data set. Cloud Firestore stores data in documents that are grouped by collections. Since documents can further contain sub-collections, we make it really easy to structure any kind of data. Cloud Firestore also supports many more data types natively, and you now also have access to data store's advanced queries. To make this an even sweeter deal, we further added one of the most asked for features of the real-time database, Web Offline. Yes, Cloud Firestore for web delivers latency-compensated local updates even when it's offline. Firestore offers planet-scale, strongly consistent reads and writes that are both durable and globally replicated. And just like the real-time database, Cloud Firestore pushes real-time updates to all your clients as your data changes. And all this is built on Cloud Data Store, Google's cloud database that is already happily servicing 15 trillion queries a month. With the new Firestore SDKs we announced last Tuesday, you can now use Cloud Firestore straight from your iOS, Android, and web app. So today, I would like to talk to you about how you can use these tightly integrated products to build amazing experiences. In particular, we will be using the new Firestore and Cloud Storage SDKs and glue them all together using Cloud Functions for Firebase. Before Cloud Functions and Firebase, you might remember that you had to set up a traditional server backend to perform even very common tasks. You might need to resize images uploaded to Cloud Storage. You might want to filter data that is stored in Firestore. You might want to send notifications when messages are posted to a chat room. But now, you can do all of this with just Firebase, and there's no need to create your own servers or to scale and manage your own backend. Cloud Functions for Firebase provides this first-class experience for Firebase developers on iOS, Android, and the web, and it's all built on top of Google Cloud Functions. This has actually been the #1 most requested feature from Firebase developers, and we hope that you're all as excited as we are. Cloud Functions for Firebase acts as our programmatic glue. It lets you extend and connect Firebase's mobile and all of Google's cloud products to create a completely serverless backend for your mobile apps. Cloud Functions are event-driven, lightweight JavaScript functions that are deployed to Google's cloud. We even promise you that the JavaScript you have to write is not as daunting as it may seem. Cloud Functions for Firebase provides developers with a dedicated SDK, tight integration with Firebase tooling, and additional Firebase-specific events. So, how does this all work? All Cloud Functions are event-driven. You specify the event your function should be triggered by. First, an event is emitted from an event provider, such as Cloud Storage. If conditions are met, your function will be triggered and a new instance will be spun up. Then, the code within your function will be executed. Now, with your code, you can also make calls to other services and APIs, As a result, you can invoke other functions since some of the services may also emit events. After your code is finished executing, your function instance is spun down, and you only pay for what you use with Google Cloud Functions. So what does this look like code-wise? Let's start with a really simple example, and let's stick to what we do best and implement Hello World. This is the simplest Cloud Function. With just a few lines of code, we've written a fully functional auto-scaling web service that responds to HTTPS calls. Cloud Functions are written in JavaScript for the Node.js environment. To define our Cloud Function, we'll use the Firebase Functions SDK. This is an open source Node module that makes it easy to build Cloud Functions. Of course, you can include other third-party modules as well. Note that in Node.js, everything is scoped to a module, and everything in a module is private unless it's exported by adding it to the global exports object. We need to export our Cloud Function so Google can run it. In this example, we are creating a function that is available over HTTPS. You even get access to the raw request and response objects, which lets you build freeform backends easily. Our Hello World app is, however, very simple, so we'll just send the same message back every single time. To deploy our function, we use the Firebase command line tool. The command Firebase deploy will notice that you have Cloud Functions in your project, analyze your code, see that it defines a Hello World Cloud Function, and deploy or update our Google production servers to match your code. This will take just a little while, and then, after the deploy is successful, it returns the URL for all of your Cloud Functions. We visit the URL and voila, we now have a scalable Node.js backend running in Google's cloud. So let's see how we can integrate the Firebase SDKs for iOS with this amazing product. And we're starting with Firebase Storage. So let's quickly discuss why you would want to use cloud storage with Firebase in the first place. The Firebase Storage SDKs allow you to upload and download large files like images, movies, audios, and so on, while gracefully handling poor network connections. It's all backed by our security rules and Firebase authentication, so you can enforce quotas and platform validation without running your own server. So let's create a file that we can upload in our iOS app. We will then upload this file to cloud storage with the Firebase Storage SDK. Here, as a starting point, we are recording audio in Swift. The code you see here resembles the standard initialization pattern for AV audio recorder, and we will use this code to create our files. When we finish recording, we upload the audio file to cloud storage using the Firebase Storage SDK. This all happens in the background in just one line of code. See for yourself how easy this is. We will then use the Cloud Speech API and Cloud Functions to automatically transcribe this audio file into text. The Cloud Speech API that we will be using allows you to convert audio to text. It recognizes over 110 languages and variants. You can even stream audio files to make your application more interactive. We will use the non-streaming variant in our example and use the Functions SDK to integrate this API with cloud storage. But how do we transcribe the audio file using this powerful API? Let's start by implementing a cloud storage trigger in Cloud Functions that invokes the Speech API. First, I will show you how you can initialize your Cloud Function. The Functions SDK has a common pattern that you are already familiar with. First, you import the Functions SDK. Then you pick the service you want to integrate with. Here, we're picking Firebase Storage, since we want to process the audio files we uploaded from our iOS app. Next, we pick the resource we want to listen to. Here we pick all files that are uploaded to Cloud Storage's root location. The onChange here simply says that we want to listen to all object changes, which includes both uploads, deletes, and also modifies. Note though that in our example, we are only ever uploading new files. Our function will be given an event object, which is actually very powerful. The event has a data field that has all the features of the object metadata object you would get from Cloud Storage. In this case, we just use the Google Cloud Storage bucket and object name to compose a simple request for the Cloud Speech API. Now that we have created the request for the Cloud Speech API, we can use the Speech SDK to process our audio file. When the Speech SDK returns a response, we store the transcribed text in Cloud Firestore. Note how simple our new Firestore API is and how easy it lets you create and manage structured data. Here, we're adding a new randomly named document to a collection named chat. In our document, we are storing both the result of the transcription, a string, as well as the time of the operation, a server timestamp. That's all we need to store the content of the audio file in our new Planet Scale database. And now, I will quickly show you how you can even more tightly integrate Cloud Firestore with Google Cloud Functions. You already saw how you can write to Cloud Functions from Firestore, but now I will show you how you can run a Cloud Function to process these database writes. We will use the Cloud Translation API to translate our English audio clip into Italian text. The Cloud Translation API translates any arbitrary string into any supported language using state-of-the-art machine translation. It's super responsive and backed by the same technology that all of you have used in Google Translate. So let's go use it in our code. Once again, we start by importing the Functions SDK and by defining a trigger. Here, we say that we only want to process newly created documents in our chat collection. Our function code extracts the data object from the functions event. The data field for Firestore has all the features of a document snapshot, as well as a few added fields that Firebase provides for Cloud Functions. Now, we look at the data that we just wrote in our Cloud Storage trigger and call the Google Translation API to translate our text to Italian. Note that we don't have to tell it what the source language is. As the last step, we persist the result of this translation and save it in Cloud Firestore. With just these few lines of code, we managed to integrate Cloud Firestore and Cloud Storage with Google Speech and Translation API. You may have noticed that by now we've almost built a complete iOS experience. So let's go full circle and give our app some finishing touches. We will go back to our iOS app and use the Firestore SDK to fetch the translated data that we just stored in Cloud Firestore. First, we initialize the Firestore client and grab a reference to our chat collection. Since we want to get updates every time our Cloud Function posts a new translation, we can simply initialize a Firestore on snapshot listener. This concept might be familiar to users of the real-time database, as this is our new API to get real-time updates with Firestore. For this specific listener, we use Firestore's advanced query capabilities to only show Italian translations and to further sort them by the time field we added earlier. Firestore now invokes our onSnapshot callback every time new data is added. Since we never mutate our data, we can simply look for newly added documents. We then extract the Italian translation from these documents before we append them to a text view. We now have built an iOS app that translates English audio clips into Italian text without writing a single line of server code. With Cloud Functions for Firebase, remember that there is no need to manage and set up your own servers. There's no need to worry about scaling, and there is no need to buy more resources. There's no need to pay for the resources you aren't utilizing either. So let's recap what we just implemented. First, we created an audio recording in our iOS app. Then, we uploaded this recording to Cloud Storage via the Firebase Storage SDK using just one line of code. Then, Cloud Functions runs our storage trigger that invokes the Cloud Speech API. The results of the Cloud Speech API's transcriptions are then stored in Firestore. Because of this, the Cloud Firestore trigger starts running and calls into the Cloud Translation API. The result of the Cloud Translation API is then once again stored in Cloud Firestore. And finally, as our last step, our iOS app picks up this change when the onSnapshot callback fires. So let's see what the final app looks like. I'm going to run the same iOS app that we just built on both an iPhone and in the iPhone simulator. As we record audio clips on the iPhone, we will follow along in the Firebase console to see what's happening. You will see the file we uploaded to Cloud Storage and the Cloud function that transcribes and translates our audio. Remember that we use the non-streaming endpoints and that you will likely want to stream your requests to our servers to make your app more responsive. Okay, so I'm gonna exit out of. Okay. So we'll just use, this is the same code you saw on the slides, except it's even smaller. I'm just gonna launch this app in the iPhone simulator, which zoom in. Okay, you can make this maybe. Okay, so this app I'm going to switch to Italian, and then I hope that I'm still connected to the right Wi-Fi here. And I'm going to use the exact same app on this iPhone, but this app is set to English, so I can speak English to this, and then it unfortunately takes a little while, but the Italian text will show up. So I'm just going to say, hello and welcome to Verona. And then a lot of things are happening right now in Google's cloud, so unfortunately it takes a while. And we'll go through this again, and I can see what's happening in the console. I can show you what's happening in the console. Okay, there is our text. Yay. Okay, so let's do this one more time, but this time we'll follow along in the Cloud Console. So this is the Cloud Storage tab. So the very first thing that happens when I speak into the iOS app is that we create a new file and then we upload it to cloud storage. So let's do that again. Verona is a beautiful city in Italy. So this doesn't update live, so we have to refresh it. And once the upload is done, you will see 2 audio files here. So the next thing that our implementation does is that it calls the speech API to transcribe this audio into text. And you can see this in the Firebase Functions log view. Okay, it already finished everything. So this is the speech execution that you see here. I'm going to try to make it bigger. This is the speech execution right here. And you see that it finished with status OK. So we can go into our database and see if everything shows up. Last Tuesday, we added this new button to the console so you can switch back and forth between the real-time database and Cloud Firestore, and you can also use them both in your app at the same time. So here you see that the text is already translated. And you can see that we also have the German translations and the French translations, and we also have the original English text in our app. So one of the cool things that we can now do is we can actually trigger our Cloud Function just by changing the data in Firestore anywhere. So it even works here. So instead of saying that Verona is in Italy, we're just going to say that it's in Europe. And then we wait a little while. And then the translation API kicks in and translates all the text. Okay. You can get ready to start clapping. Okay, it worked. And already in our simulator, the new text shows up. Okay, that's pretty much it for our demo. I can go back to the slides, and we're also almost done. So yeah, we have a couple of code labs and samples. This is the link to our GitHub. You can also just search for function samples. That shows you a bunch of samples in Node.js that tell you how to do things like transcribe audio, resize images, and so forth. We also have a code lab that helps you get started with Firebase functions, and there are also code labs that show you how you can integrate all of our SDKs with iOS. So thank you very much for coming.